Hello, so this week we are going to close out all of the new material of Algebra 1. Oops. So what we have is that this year we've learned three big things. So at the very beginning of this year, we talked about linear functions. So that was y equals mx plus b. We talked about slope and graphs and how to graph lines and inequalities and systems. So that's what we began our year with. And then we moved into quadratic functions, which is the U-shape function that's called a parabola. And we talked about all of the components of that. There was a maximum, a vertex, axis of symmetry, solutions, zeros, roots, etc. And then we just finished up the exponential functions unit, which meant that we started with an initial value, and then we had a multiplier, and that was either exponential growth or exponential decay. So now that we've done all three of the big topics of Algebra 1, we're going to go back to linear, and this week we're going to spend our final week of new material closing out the last little pieces of linear functions. So in linear functions, what we know about linear functions is that we have graphed them, we've written their equations. What we're going to do today is look at patterns. So what is a pattern? So let's look at a couple of examples here, and we'll be able to see if you can recognize the pattern. So this here is in your newest packet. If you are online, you can find these notes on the Go Formative, so you can open them up and follow along as we go. All right, so in this first one here, when we look at patterns, we're going to bring this back to, I don't know, second grade, third grade, whenever you learned this a while back. So if I look at the number 8, 10, and 12, I notice that there's a pattern. To get from 8 to 10, we can get there by adding 2. To get from 10 to 12, that's also plus 2. So the next three numbers of the pattern, 12 plus 2 is 14, 14 plus 2 is 16, 16 plus 2 is 18. So what is the pattern? The pattern is that we are adding 2. So we notice that we add 2. Go ahead and try the same thing here. From 2 to 6, from 6 to 10, what's that pattern? So in this pattern here, they are adding 4. 2 plus 4 is 6, 6 plus 4 is 10, 10 plus 4 is 14, plus 4 is 18, plus 4 is 22. So again, there's a pattern, and the pattern is that we add 4. Okay, go ahead and try this next one on your own. Once you figure out the pattern, you can write that on your own paper or in the Go Formative, and then tell me the next three numbers of that pattern. Okay, and this last one here. So in this pattern, from a 50 to a 40, we're subtracting 10. From 40 to 30, they subtracted 10. So that's my pattern. I'm going to continue to subtract 10, subtract 10, subtract 10. So the pattern is that we subtract 10. Okay, so a sequence is a pattern of numbers. A sequence is a pattern of numbers. Let's look at that here. Here we go. So that exact definition. And arithmetic just means math, numbers, patterns. So arithmetic just means that we have a sequence that is a pattern where the numbers add or subtract. The common difference is the number you are adding or subtracting by. Easy. Okay, so for numbers 1 through 4, let's see, is this sequence arithmetic? What that means is there a pattern for each of these numbers that's the same? So let's see, from 8 to 10, we add 2. From 10 to 12, we add 2. 12 to 14 plus 2, 14 to 16 plus 2. The answer is yes. The common difference is the number that we are adding or subtracting. So this common difference is 2 because they're adding 2. This next one appears to be a little bit more difficult because there's lots of negatives. But we're going to do the same idea. To get from a -4 to a -6, we subtract 2. To get from -6 to -8, -2, -8 to -10, -10 to -12. So again, yes, there is a pattern, and the pattern is that we are subtracting 2. Next. So in this one here, to get from a 1 to an 8, we add 7. To get from an 8 to a 10, we add 2. No, this is not an arithmetic sequence because this number, there's no common difference. That number is not the same. So there is no, and then we don't have to put anything for common difference because there isn't a common difference. There isn't a single number that they're adding or subtracting by to get to each number in the pattern. Okay, one more. To get from a 0 to a -3, 0 minus 3 is -3. To get from a -3 to a -9, that's -6. Again, this is no, because this difference is not common. That's -3. And this is -6. Those numbers are not the same, so there is no common difference for this here. Okay, so this is what we're going to mess with today. So we have a list of numbers, and we have an arithmetic sequence, which means that there is a pattern or a common difference that we use to add or subtract these numbers. So what we're going to do today is a little bit of math magic. Whoop. What that means is we're going to test your math skills. Let's see how smart you are here. Okay, so how this works. 10, 15, 20, 25. What is the 6th number in this term? What is the 6th number in this term? We're going to pretend you don't know. So in this one here, the 6th number in this term, let's first figure out what this is. So what's happening is that we are adding 5. Add 5. Add 5. So the next number would have to be 30. Add 5 again, that's 35. So this is the 6th number. Number 1, 2, 3, 4, 5, 6. So the 6th number of this term is a 35. Let's try that again. So this question here, how low can I go? Here we go. All right. What is the 7th number of this term? So let's see. Plus 10, plus 10, plus 10. So the next number would be 50, and then 60, and then 70. First number, second number, third number, fourth number, fifth number, sixth number. The 7th number is the number 70. So we can use a pattern or arithmetic sequence to figure out a certain number in a term. So now, what if I said, what is the 114th term in this sequence or in this pattern? Well, that is crazy. I'm not going to sit here and add 2. So I see that this is plus 2, plus 2, plus 2. I'm not going to do this 114 times to figure out what number is sitting in the 114th spot. So what some brilliant mathematician did, so a math genius came up with a formula that allows you to guess any number in a pattern. So if we have a sequence of numbers, this here is called a sequence of numbers. Here they are. If we have a common difference, the number that we're adding to each, I can tell you what any number along the term is. Okay, so let's learn it. So in your notes, go ahead and find this here. So what we're going to do is we're going to start by figuring out what the common difference is. That's called D for difference. The common difference is how much it changes, just like slope. When we did this way back in the beginning of the year, this number in front was like the slope. That's how much it changes. Then in parentheses, we're going to put the desired number. What number do they want? That's the input, or the desired number, minus 1. And then we're going to add our starting number, our beginning number, our y-intercept. Okay? So that's what we're going to use to figure out this here. Here we go. Let's plug it in and let's get an answer. Okay, step 1. Number 1, I need to find the common difference. To get from a 1 to a 3, we add 2. To get from a 2 to a 5, we add 2, we add 2, we add 2. So I know that the common difference is 2. Then the n is the desired number. The desired number is written little right here. So the desired number that it wants is the number 23. It wants to know what is the 23rd term, what is the 23rd number in this list of the sequence. So 23 is the n, that's my desired number. Minus 1 is part of the formula, plus the a1 is the starting number. My starting number for this example was a positive 1. Okay, so now we're going to calculate. 23 minus 1 is 22. 2 times 22 is 44. 44 plus 1 is the answer, 45. Okay, I'm going to do that with you one more time, and then you can try 3 and 4. All right, number 2. So number 2, step 1, I need the common difference. I need to figure out what the D is, the common difference. To get from a 20 to a 25, they add 5. To get from a 25 to a 30, they add 5. They add 5. So that's my common difference, is a 5. Then it wants my desired number. The desired number is the number that's written here. It's a 10. And then there's a minus 1. Then we're adding A1. A1 is the first number in the list, which is 20. So now we can clean this up. 10 minus 1 is 9. 5 times 9 is 45 plus 20. 45 plus 20 is the number 65. So the 10th number in this row would be the number 65. So we use this formula to figure out any number in a sequence. So let's try 3 and 4. The only thing I'm going to help you with 3 is your common difference. If you're at a negative 20 and you want to get to negative 25, you're subtracting 5. So your D, your common difference, is negative 5. Okay, the n that it wants is 100. The formula says put a minus 1 plus my A1. My A1 is negative 20. A plus negative is the same as just writing minus 20. Okay, simplify. You can use a calculator if you need to. And tell me what the 100th term in this sequence is. Then when you're ready, give me the same thing for number 4. Nice and easy. Okay. Try the same thing for 5, 6, and 7. I'll write your formula here. So you start by finding the common difference. Then you put the desired number minus 1 plus your starting number. This is very similar to the beginning of the year when we said that we have a change number that's m, x minus x1, and then this is my y-intercept, or my y1. Okay, so what is the difference, the common difference? What number are they trying to plug in? And then you add your starting number. Not too bad. All right, then we get to number 8. So in number 8, it looks a little different, so I'm going to do 8 with you. So in number 8, let's write the formula. We know we have a common difference, and minus 1 plus my starting number. This one's even easier. They give you the common differences too. They give you the desired number. It wants to know the 34th number in the term. The minus 1 comes from the formula. And then my starting number is 8. Easy. So 2 times 33 plus 8. 2 times 33 is 66. 66 plus 8 is 74. So the 34th number in this list of numbers would be the number 74. Okay, try the same thing for number 9 and for number 10, please. Very easy, same formula. Common difference, desired number minus 1 plus your starting number. Okay, so now that we have practiced figuring out where a certain number is, we are now going to use the first term in the common difference, just like we just did. The D is the common difference, the A1 is the first term, and we're going to identify the first 4 terms in this list. So this next one is called the recursive formula. It seems difficult, but it's not that bad. So the way that I like to do this to make it as easy as possible is I like to draw a chart. N is my number here. So what we have is we have a first number, a second number, a third number, and a fourth number. So if you look here, A1, the first number, it says is the number 8. Then it says take that number 8 and add 6 to it, plus 6. 8 plus 6 is the number 14. And then just keep adding 6. 14 plus 6 is 20. 20 plus 6 is 26. So the first number of this pattern is an 8. The second number of this pattern is a 14. The third number is a 20, and the fourth number is 26. So this is very similar to what we did with exponentials. So in the last unit, we started with a starting number that they gave you. We called that one the initial value because it had 0 in it. So that's what we did for the last unit. We had a starting number, and then we had a multiplier. So exponential meant that we had to multiply. Well, now that we're back to linear, we're not multiplying, we're adding. So in a linear function, we have a starting number, and then we add a number to it. So let's try the same idea one more time. So I'm going to make it into a table so it makes some more sense. The desired number, I want to know the first number, the second number, the third number, and the fourth number in this table. It tells you right here, the first number is a 5. Then this is what we have to do. Then we have to add 4 to it. That's 9. Add 4 again, that's 13. Add 4 again, that's 17. So these are the first 4 numbers in my sequence. Okay, so A1 just means where we start, and then whatever number here just means what we're adding to it. Not too bad. What are the first numbers of the sequence? We start at 5, and we're adding 4, adding 4, adding 4. Okay, try the same thing with number 3. So you have a starting number. You can draw a table if you want to. If you don't want to draw a table, you can just say that the first number is -2. And then from that first number, we need to add 10. -2 plus 10 is 8. 8 plus 10 is 18. 18 plus 10 is 28. Common difference says that we're adding 10. The starting number says to begin at -2. So you can make it on a table, 1, 2, 3, 4. We started at -2. This is my starting number. And we add 10 to it. So you can make a table, or you can just put it right on the line. Same thing. Okay? So what does the formula mean? So on your notes, you can write this down. So what they're doing is they're taking the previous number. So this just means the previous number, and then you're adding the common difference to it. So if my previous number is 10, and then I'm adding 2, 10 plus 2 is 12. 12 plus 2 is 14. 14 plus 2 is 16, etc. A1 is always going to be the first number in your pattern. Okay, we'll do that again. So in this one here, A1 is 8. So I'm going to start at an 8. Then it says your common difference, take the previous number. The previous number was 8, and add 6 to it. 8 plus 6 is 14. 14 plus 6 is 20. 20 plus 6 is 26. So you can just put this straight on the line if you want to. Okay, go ahead and try number 5. Very easy. And then try number 6. You have a starting number. Starting number is your A1. You're going to write that number on your line. Then you take the previous, or the starting number, and for this one, it wants you to subtract 1. Subtract 1. Subtract 1. See what you get here. Okay? So the last thing of today, we're going to do that one more time. It's the exact same thing, but we're going to use f of x instead of the letter a, or f of n in function notation. Okay, so it's the exact same thing. So what this whole big old block just means is we take the previous number, so whatever number you have, that's the previous number, you add the common difference, and then you start with your starting number. Okay, same as before. So this is the first number in the pattern. If you want to see it, I'll show you both ways. So as a table, so that we have first number, second number, third number, fourth number. So in this one here, it says the first number is an 8. So I know that 8 is my first number. Then it says take that previous thing and add 4 to it. 8 plus 4 is 12. So the second number is 12. 12 plus 4 is 16. That's a 16. 16 plus 4 is 20. Okay? Same thing we just did. So this is your starting number. The first number in my pattern is a 1. Then it says take the previous number. Don't let the notation confuse you. Take the number you just wrote down, the previous or the starting number, and you're going to add 2 to it. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. Super easy. So I want for you to try the same thing with numbers 3, 4, and 5. So what we learned today is in an arithmetic sequence, we have a sequence of numbers that are being added or subtracted by the same thing, plus 6, plus 6, plus 6. And they're always going to give you a starting number. So where we start, and then what we do to that starting number. Not too bad. So go ahead and try 3, 4, and 5. Next class, we're going to move into line of best fit, which is very easy, more linear stuff, as we finish up the rest of the algebra of this school year.